Yeah, this is question number 2. Now, for the first part of question number 2, you're given a differential equation, and then this is your initial condition. You're told to find an explicit solution. To find an explicit solution. Now, to find an explicit solution in this case, what we first do is we want to solve the differential equation so that we can find a general solution, after which we use the initial condition to find a particular solution. So what we have is the dx equals y squared minus 1 all over x squared minus 1. I only rewrote the differential equation back here. So like I said, if you're trying to solve a differential equation, the first thing you want to think about is, what is the first technique I'm going to use to solve the differential equation? We have several techniques, but the first one you might want to think about in using is it possible for me to separate all the variables, that is to put all the y's on one side and all the x on one side? So let's see. Now these are the y's, while these are the x. These are the x here. So it's possible. I bring my x here and I bring my y to this side here. That's all we do, and then we are on track. So let's see. So we have dy divided by y squared minus 1 equals dx all over x squared. So this is x squared minus 1. So the next thing is we integrate both sides with respect to this variable here, y and x. So like you can see, the next thing is to integrate this, we have to resolve this into partial fraction. So that's going to be 1 over y into y minus 1 dy equals the integral, that's the x, all over x into x minus 1. So you try and see if you can resolve this into partial fraction and then compare your answer with my own answer in the next few seconds. Yeah, we're back. So tell me, is your answer the same with mine? When you resolve this into partial fraction, this is what you should get. 1 over y into y minus 1, you should get this. And then the same thing, when you resolve this into partial fraction, this is what you should get. So I hope we got the same answer. If you have not gotten the same answer, check my last video and then see how we resolve stuff into partial fraction. Now, having resolved this into partial fraction, the next thing is we integrate. Now integrating this is 1 over 2 into y negative 1, so that's going to be 1 all over 2 the ln of y minus 1. Now I'm gonna do away with this when I'm trying to. Okay, anyway, we'll see how we'll do that as we keep on going. Minus 1 over 2 the ln of y plus 1. Now equals, the same thing happens here. You have 1 over 2 the ln of x negative 1 plus 1 over 2 the ln of x plus 1. And then, like I told you, if you're going to put an arbitrary constant here, so it makes more sense since we have ln on all sides. So let's leave our constant to be in ln form. It's still a constant, it's representing a constant, so there's no problem. You've not made any fallacy here, any mathematical fallacy. So our aim is to find y. We want to find an explicit solution, actually. That's what we want to find. So the next thing is this. So this implies that, so you have half is common in the two of them. Then the ln, then we apply the laws of logarithm. You have ln of y minus 1 all over y plus 1 equals, now the two of them here too, half is common here, half is common. So doing that, you have half into the ln of x minus 1 all over x plus 1 plus the ln of b. Now this is the same thing as the ln of, so this actually comes here, still using the laws of logarithm, y minus 1 all over y plus 1 to the power half equals, so you have ln of x minus 1 all over x plus 1. So the same thing happens here too. This man here comes here to the power half plus ln of b. So right now in this side here, we apply the laws of logarithm here, so this is going to be this plus this, so we apply multiplication rule, so that will be b into x minus 1 all over x plus 1 to the power half. So what we have is still the same thing as saying you have ln of y minus 1 all over y plus 1 to the power half equals the ln of b into x minus 1 all over x plus 1 to the power half. Now if the ln of this equals this and ln of this equals this, that simply implies that this and these are equal. So because of the absolute sign, what we have is y minus 1 all over y plus 1 to the power half equals plus or minus b into x minus 1 all over x plus 1 to the power half. So in continuation, we have y negative 1 all over y plus 1 to the power half equals plus or minus b into x minus 1 over x plus 1 to the power half. So now this is the same thing as y minus 1 all over y plus 1 to the power half equals, so I could rewrite this as my plus or minus b is a constant. Let me call that k. K into x minus 1 all over x plus 1 to the power half. Now the next is, this is still a constant. To make my whole work simpler, I'm going to rewrite this again in, now you watch what I'm doing, it's going to be y minus 1 all over y plus 1 to the power half equals, so to make this and this to have the same powers, I could just call this, I could call it, let me call it a to the power half into x minus 1 all over x plus 1 to the power half. So now what you'd observe is my a here to the power half is representing k. So you should note that a to the power half equals k. It's still a constant. So that's the beauty of the whole thing. You see, all these constants, they have flexibility. You could just be changing them along what you're trying to solve the differential equation. But always keep track of your change so you do not mess up with the variables. So now since we have this, so this is the same thing as, you still have this like this. You have y minus 1 over y plus 1 to the power half equals, so here you have a into x minus 1 all over x plus 1. So I could bring a bigger half here, half outside. So if that goes on, then this goes off, then we have this equals this. So this implies that, y minus 1 all over y plus 1 equals a into x minus 1 all over x plus 1. So I want to make y the subject of this equation here. Now to make this whole thing simpler, I'm going to represent this stuff here, and it's the whole of what we have here. Let me call this, I'm going to call it big S. So I can easily make y the subject of the equation here. So let's see how we do that. Now we have y minus 1 all over y plus 1 equals big S. So when you cross multiply, you have y minus 1 equals big S into y plus 1. So when you expand this, you have big SY plus big S. So when you collect like terms, you have y minus big SY equals, then this man here comes to the other side, equals S plus 1. So when you make y the subject of the formula here, you have 1 plus S, then y equals 1 plus S divided by 1 minus big S. So we can now come back here and rewrite it as 1 plus big S. Our big S is this, that's a into x minus 1 all over x plus 1. So that's what we have here, divided by 1 minus a into x minus 1 all over x plus 1. So all I just did was assuming you are not given an initial condition and then you are told to find an explicit solution of that's the general solution in explicit form. So what you would have gotten is y equals this minus this. But since we are given an initial condition, you might not necessarily need to go through all this step here. From this point here, I could just simply substitute my, since y equals 2, so I substitute 2 here for here, and then 2 here, I substitute in here, and then when y is 2, x is 2, or when x is 2, y is 2, anyhow you want to write it. So this one comes here, and then also here you have 2. So when you substitute this and this into here, what you would later have is going to be, so you have 2 minus 1, that's going to be 1, all over 2 plus 1, that is 3, equals a into 2 minus 1, that is 1, all over 2 plus 1, that is 3. And then when you simplify, you have your a to be equal to 1. So all you need to do is, when your a equals 1, then make y the subject of the equation from here. So you have y minus 1 all over x, or all over y plus 1, equals x minus 1 all over x, x plus 1. So from here, when you make y the subject of the equation, you're going to have y to be equal to x. And then this completes the solution of this problem here.